So let's see the next type of model, which is dynamic Smagorinsky model. This is by far a very popular model used in most of the commercial solvers and open source codes. Dynamic Smagorinsky. Smagorinsky model is also very robust, provided you know the model constant, what to use. Otherwise, this is popular, a dynamic Smagorinsky model. The reference for it is Yermano et al. 1991. So as I said, in this model, in this SGS model, the Smagorinsky constant that is the CS is not user dependent, but calculated, that is it's dynamic. So this particular approach where the model constant in SGS model is computed rather than fixed by a user is also used in other modeling approaches. For example, you can take a note. We'll not go into this models, but you can, the concept is similar. So similar approach is also used in, that is dynamically computing the model constant. Similar approach in what is called a VMS model, that is variational multi-scale, and Wall model, that is wall adapting local eddy viscosity. But we will come back and focus on the dynamic Smagorinsky model. Okay. So what we do first in a dynamic Smagorinsky, as I said, we have to compute the model constant dynamically. So that means we here define what is called a test filter. Okay. So first we define a test filter. So what is this test filter and why it should be different than the grid filter is that this test filter, let's call this, I use a cap here. Okay, this test filter is twice that of your grid filter. Okay, so here where delta is your grid filter, that is filtering operation done at the grid level if you are using implicit filtering, right? So grid filtering, and this is the test filter. This kappa is the test filter. So that means even in finite volume method, if you are using implicit filtering, that means your grid size acts as a filter size. When you use a dynamic Smagorinsky model, you must do an explicit filtering operation, right? You actually took advantage of finite volume method where you are not doing actually a filtering operation at all. The grid size was acting like a filter size, right? But if you use dynamic Smagorinsky, one filtering operation has to happen. You need to do additional calculation here. So there is a computational cost will slightly increase compared to a Smagorinsky model. Okay. So now why do we define this is basically we will see what advantages it would bring to compute that model constant eventually. So schematically I can write this as, let's say I have a grid, I am writing this in 1D, say this is delta x, Okay. Those who are familiar with finite volume terminologies, I call it P node, east node, and a west node. So now we are going to do a so this, what I have written delta x as, let's say this is the grid filter. This is your grid filter size. So the test filter is twice that of that. So this will be like, so this is 2 delta x here, delta x, right? So this particular part is your test filter. I'm writing it in 1D for easy illustration. So we define a test filter twice that of the grid filter, and we apply this filtering operation to Navier-Stokes. Okay, so let's start with Navier-Stokes equation. So consider NS equation, which is dou ui by dou t plus dou by dou xj ui uj equal to minus 1 by rho dou p by dou xi plus nu dou square ui by dou xj square. Now first we filter this on the grid level, that is grid filtering is applied. So apply grid filtering. Okay, so I get essentially, if I just take the same equation here, copy it, so I'm applying the grid filtering operation. This of course does not have the convective part that we already know that we added. So you can add a convective part here, that is plus dou by dou xj of your ui uj grid filtering on both sides, right? So here also you can add, or I'll just add it here, dou by dou xj ui uj is added on both sides, the convective part. This is the convective terms added on both sides. Now we apply test filtering. So this of course, up to this you are anyway computing on your LES. The test filtering operation we have to do. So apply test filtering. Okay, to, let's call this equation 1 here to this part. To equation 1. Okay, so if I do this, I would get, so I have dou ui by dou t plus dou ui uj by dou xj equal to minus 1 by rho grid filtered pressure gradient and also the grid filtered viscous term. So now I am going to apply test filtering on all this. Again, this equation does not have a convective part, so we add that again here, adding the convective term to this equation. So I have dou by dou xj ui bar uj bar. We are essentially getting a filtered Navier-Stokes equation at the test level. Okay, the previous one was at the grid level, this is at the test level. So again I add it here, dou by dou xj ui uj at the test level. Okay, again same arguments, convective terms added on both sides. All right, so now what do? We simply rewrite this equation here. So I get the left hand side part, dou ui bar by dou t, plus I take the convective term here, ui bar uj bar by dou xj equal to the pressure term, dou p bar by dou xi, the viscous term, nu dou square ui bar by dou xj square, and of course the subgrid stresses at the test level. Okay, so that will be minus of, I'm moving the one term to the right hand side, so I get minus dou by dou xj of, I have ui uj average test filtered minus ui bar uj bar test filtered. Okay, so this is the stress at the test filter level. So I'll call this not tau ij but Tij SGS at the test filter level, this particular term here. But what is this particular ui uj over bar? If I go and look into equation 1 where we added the two convective terms here, here in this equation if I rearrange here, the right hand side part tau ij SGS, we already know tau ij SGS, by moving one term to the right hand side I would get ui uj over bar minus ui bar uj bar. This is your SGS stresses, right? So using this, let's call this star. Now using equation star in this final equation here, I can see that ui uj bar is nothing but, right? So here, or I can say ui uj over bar is nothing but tau ij SGS plus ui filter uj filter, grid filtering. So I can substitute this particular term in the Tij SGS, test filtered level. Okay, so I get essentially, so the left hand side terms remain same, equal to the right hand side part, the pressure minus 1 by rho dou p by dou xi test filtered, the viscous term and then we are substituting for that tau ij SGS here. So I get minus dou by dou xj of, so ui uj bar is replaced by tau ij SGS plus ui bar uj bar. But this entire term ui uj, if you go back to the previous slide, you can see here you can see this ui uj bar had a test filtering operation. So we are replacing this ui uj over bar with tau ij SGS plus ui bar uj bar. okay, and a test filtering over this here. So I get a test filtering operation over this entire part here, okay, and then minus I have the other two terms, which is UI bar test filtering, UJ bar test filtering here. So I get UI bar test filtering, sorry, and then UJ bar test filtering. Okay, so this is your entire Tij SGS, this whole thing. So if I go back to the previous slide, so see this, that this tau ij SGS, what I have written here, this is applicable at the grid level, right? Tau ij SGS is at the grid filter level. So now what do I have it here? This is applicable at the test filter level, Tij SGS, okay, at test filter level. So this at test filter level, that means, so if I go back here and then see tau ij SGS, here for all length scales less than the delta only this tau ij SGS is applicable, right? Up to delta you are resolving. All the turbulent scales up to delta, it is being resolved. Scales, turbulent fluctuations or scales smaller than delta is not being resolved, and that is modeled. So this tau ij SGS accounts for all the subgrid scale stresses for L less than delta, correct? Grid filter level, that is where L is less than delta for all the SGS length scales smaller than the filter size. So if this is L less than delta, at the test filter level this has to be L less than 2 delta, right? At the test filter level. So that means here this is applicable for L less than the test filter, okay. So then obviously that means for all L, for all scales in between the grid filter level and the test filter level, an intermediate level, that L will be in between this, and the subgrid scale fluctuations or subgrid scale stresses in between the test filter level and the grid filter level is called dynamic Leonard stresses, and intermediate stresses, okay. So what we do now is we define what is called a dynamic Leonard stresses, which is nothing but, let's call it Lij, which is equal to this Tij SGS, okay. So this Tij SGS is equal to these three terms. So if I subtract tau ij SGS filter part from this, okay. So before I introduce this, I can simplify this saying that, see, the tau ij SGS, what we have got is nothing but tau ij SGS plus UI filter, UJ filter, and then there is a test filtering operation. Now test filtering or any filtering and addition commute, so I can do test filtering of this plus test filtering of this, okay, and then I have minus UI grid filtered, UJ grid filtered, and then of course a test filtering operation. So this is again at the test filter level. This particular term is at the grid filter level. So if I subtract one from the other, I will get the intermediate part. That is what is called a dynamic Leonard stresses. So Lij is nothing but Tij SGS minus tau ij SGS test filtered okay, which is equal to UI grid filtered, UJ grid filtered, test filtering minus UI bar, UJ bar, test filter. So this of course here, this is at the intermediate level, at intermediate level this, so that means it is for all delta less than L less than test filter size. Now you may wonder, why are we doing all this test filtering, Navier-Stokes ones, grid filtering? Huh? Are we heading somewhere? Can you see this Lij equation? Do you see something useful here in the dynamic Leonard stress? Look at this term. Do you is it an unknown or is it known for you? It's known, right? See, eventually in the LES you are computing the velocities at the grid filter level, right? So at, and then you are making one test filtering operation, let's say at every time step. Okay, you are stopping the simulation, doing test filtering, and then time marching again. So UI bar is available to you. You just need to do one test filtering operation at a filter size twice that of your grid filter size. So what I have here is the Lij is available to you, and this is exact. You don't need to model this, right? You have an exact term. You can compute this easily, right? So this dynamic Leonard stress or an intermediate SGS stress is used to actually get an equation for the subgrid scale constant. The ultimate aim is to find that constant CS instead of giving a value, right? For that, we first, this is one step is to get this dynamic Leonard stresses. Okay, so we will see later how to actually get this constant C dynamically.